Hi all. Good morning.
Yeah, hi, good morning.
Okay. So okay, today we are going to see some plots. Okay. And 20. Okay. Oh, it's 9-1 only. Let people join. Styling. We've seen some styling yesterday. Heat maps. Interactive table. Okay, we'll start from here. So so Kiran, you pasted something. What is that?
Good morning, Ashish.
Good morning.
Yeah, it is a video which says like the how cohesive is different from ChatGPT and Bard, and what are the added features that we get. Which
Oh, that Chinese product that we were seeing yesterday.
no, cohesive is like a local product. That is Ernie. Chinese you are saying is Ernie. There is one more Russian also.
So you are doing some research on different countries' product?
Well, you see, Ashish, maybe like in 1 or 2 years, every country will have their own version. That is the latest development.
Okay.
So even Saudi is
And
thing which will roll out in maybe August.
Oh, so let's see what is happening. It's like totally unpredictable now.
A lot of traction happening in this chatbot.
Lots of things are happening. People have suddenly moved from data science towards this bot and all.
Yeah.
They're forgetting like that data science also playing a crucial role.
Well, the main reason, Ashish, it is like seeing whatever the informations what we are getting, it is only country specific. I told you, right, there are many financial and geopolitical reasons behind it.
So this one is not taking prompts or something. This is
It has.
So it's like end chat GPT prompt struggles, create, refine, edit, and publish seamlessly with cohesive.
Yeah, what it is, the first line meaning is like ChatGPT, it is struggling with prompts, and this doesn't have that kind of glitch.
Oh, okay.
You can add directly videos, photos, whatever you want. Like say, for example, you published your paper. Say for ChatGPT, you have to go for external plugins. Here you have built-in. You can add pictures.
We'll come to this part. Yeah, anyone also saying, someone else also saying something?
yeah, I said good morning.
Yeah, okay. Good morning.
And also in AI, in yesterday in Odisha, and private news company launched an AI to read the news actually, and real news reader.
So the point is here, guys, now this is all started now. You are going to see everything in AI now, everything. So this is whatever we are seeing, everything, everywhere AI will be implemented. That is going to happen in future. That is for sure. That is definitely for sure. But yeah, so many products. People started, building different AI tools like anything here. So I'm also in that race. I'm not denying that. I'm also playing with AI and all. So this AI image generator, image editor, whatever you are doing, everything is going to change. So
So
everyone is
adding to what like Dinesh just said, the Orissa government has launched the AI newsreader. Her name is Lisa.
yeah, already I had a discussion with uh, I was like already I sent a mail to the CM office here regarding that. So there is a discuss. Actually, a few of my friends are government officers here, so college friends. So they are
Okay.
helping me out to reach out the Odisha government, because I also want to develop, because if we develop our own area, I think the whole nation will get developed in this, and we can challenge. So whatever we are talking here, like AI is going to dominate human race and all in future. So for that only, we have to know the AI things in our area first. Then only we can, stand against that situation if that will happen in future. So the point is
Right.
here to explore. Okay, we'll this, and one more thing, guys. Today we'll wind up a bit early. I have one important work at 11, so we'll wind up at 10:55 today. Okay,
Sure,
so
Ashish.
yeah, so please bear with me that for today. So 10:55 will wind up today, because 11 I have one work actually. Okay, so okay, we will discuss that. It is a never ending discussion if we'll discuss that. So we have every day, so we'll do that. So and by opening that tool, it crashed my browser. That AI. So Kiran, what you said, that one cohesive, it crashed my browser. Not sure what happened. Okay. So histogram. Uh, this one we already have seen. Can you recollect histogram?
Yes, sir. While
Where?
seeing distribution, we have seen the graphical view.
Right, right, right. Exactly. So this one, I think you guys are already known. It's not a new thing to you. What is? Just tell me these three things about histogram, then I will understand that you got the concept. Central tendency, variability, and skewness.
Central tendency would be the mean.
Mm-hmm.
Variability would be the like variance, and skewness will be through standard deviation.
Yeah,
So
skewness, as we said, like left skewed, right skewed, like that. That is the
the
skewness.
data distribution. So you guys are correct. So three of you are correct. So this is mean. This is standard deviation. Variability means what? That variance.
How distribution
Variance.
data is from the mean.
Yeah, variance. And skewness is the distribution of data towards, like whether it is evenly distributed or positive or negatively skewed. Okay, the distribution of data. Okay, so that means this one is okay. Like I think this right? Plot.hist, and the data I'm generating, and just to let me run this and show to you that one. Cell is already running. I can't see it is running. Some issue is happening today or what? Okay, okay, connecting. Great. So histogram will help you to find the data distribution here. Oh, okay. Right. Now, box plot. Did you guys hear about box plot before? Or this is the first time you're hearing?
Candle-like plot.
Candle.
Okay.
That is interesting. Like this one you're saying?
Yes, sir.
Okay. So guys, I'll tell you, okay? These plots is going to help you to do the EDA, okay? Exploratory data analysis. I think in this batch, I think Silpa is aware about that. We have already discussed that in evening batch. Apart from her, I'd like to tell you about EDA means what? You are going to know your data first, right? That is the analysis that you are going to perform on your own data set. Using this plots, your box plot, histogram, and we are going to see some other plots called violin plot. Using those plots, it will be easy for you to understand your data. When I say understand your data, I am talking about this mean, variance, and skewness only. Okay. And what is this one? This one is called box plot. The name itself suggests, right? This part, the box part. Because of this, it is called box plot. And what is this thin line? This is called IQR. Okay. This box is called IQR. IQR means interquartile range. Suppose you have data, suppose 100 data, 25th percentile. What is percentile, guys? What is the difference between percentage and percentile? Anyone?
A percentile will be we are acquiring the data in the 2.5, 0.2, 25th quarter means we are going to get the data from 2 to 3, in between the 2 to 3 on the data value.
So suppose I have marks of 100.
25th percentile means the correct 25th percentage.
Correct 25th percentage.
No,
Yeah.
no.
Right,
The,
percentile means
whatever,
maximum.
whatever the
is
data
equal to
size,
max.
we are dividing the data size up to 5 level, minimum, maximum, Q1, Q2, and Q3. In that,
No, that is interquartile range. The simple question is like, what is the difference between percentage and percentile? I'm not talking about interquartile range or any range of 5 division and all. Just what is the difference between percentage and percentile? Simple. Like you have 100 students mark. What is means by 25%? What we mean by 25th percentile of this mark?
Percentile is with respect to the maximum marks anybody has achieved, and percentage
Okay.
will be with respect to the total maximum marks that is possible in that exam. Suppose if it is a 100-mark exam and the maximum anybody has scored is 90. So the for percentile, 90 would become my base to calculate the percentile. And for percentage, the maximum marks, that is 100, that would be used to calculate the percentage of my marks.
Yeah, that making sense, but in a simple term for everyone. So when I say 100 students, when I say 25 percentile, what does that mean? That means it is the rank under which 25 people are there. So if 100 students mark, I'll sort from increasing order, and I'll calculate 25th percentile there. What does that mean? That means the mark at which point the mark is below 25. So all the persons who is below 25 and above to that is 75 percentile. That means what? 75 people are above that mark. 25 people are below that mark. Okay, so I would suggest I will not go to the discussion of percentage and percentile here. Try to find the difference. Okay, this is a basic concept. So here in box plot, that percentile concept is being used, and in your data set you have to find it to first quarter. What is quarter means? First quarter means quarterly result means we use these quarters, right?
1/4 of the data.
1/4.
So to like 25th, if you will divide your data into four part, right? So first quartile is first quartile to third quartile range. That means 25th percentile to 75th percentile of your data is called what? Q. That means what? Q3 minus Q1. Okay, that is called your what? Interquartile range. 21st quarter, third quarter, between those data falls, right? So this box is the interquartile range of your data. Okay, and this is your minimum value, the left hand side of this, and this is your right hand side is the maximum value of your data. So if you take your data and plot a box plot, it will give you like this, a box in the middle, which is the IQR range of your data, quartile 1 to quartile 3. And this is your minimum value of your data, and this is your maximum value of your data. What is this orange line? This is the mean of your data. This is the mean of your data. Now, what does this mean? Suppose this orange line is here, not here, not in the middle, in the here. What does that mean? So that means your data is something like this. Your mean is towards negative side. That means how the data I should draw?
Right skewed, positive skewed.
Positive skewed or negative skewed? So mean is towards left side. Now I am confused. This is an interview question, guys. Okay, positive and negative skewed. I saw you that mean was falling somewhere, right? Here, this picture. Mean will be at left in the negative skew, isn't it? Right, Silpa?
The
See
left
here.
positive, right? Okay.
This one. See, if it is negatively skewed means what? Towards negative side, the data is more distributed. And if it is negatively skewed, the mean will be at
Left side.
left. If it is positively skewed, the mean will be at right. Right.
Okay.
So here that means if this line is not here, so this line is not here, instead of it is here, that means your data is negatively skewed. Okay, if this line is here, that means your data is positively skewed. Okay, so this kind of questions are also come by asking like, if it is my mean, which type of distribution, which type of data you are going to follow. So this line will now tell me here in this curve, what is the mean value? Let me close this one. What is the mean value here falling? Is something
Symmetrical.
around here.
Minus 0.
Minus something like that. But what, how you are going to distinguish from the graph? So I told you yesterday, right? Whenever you're going to do some EDA, after plotting the graph, you have to write something in the below to that, the points that you are observed. So this point you are going to write, the mean of my data is at this. Okay, this is the minimum value, this is the maximum value. And one more thing, utilization of this box plot to find the outlier. Now outlier, we have dedicated session for that in this module. So we are going to see how to handle the outliers. But as of now, let me tell you what is the outlier. Anyone wants to give a try? Have you heard about some outliers?
The data is not between the range, it comes out of the range.
Okay,
Maybe
out of the range. Okay.
It is far from the behind
Mhm.
value.
So what will be the impact if we have the outlier in our data? Whether that is going to impact anything, or that is fine, that if we have any data outside of a range also, that is fine. So first of all, what is outlier? Everyone, for outlier means in a layman term I can say the friend who is not in your group. Okay, he is sitting always outside of your group, but it will be with you but not sitting with you. It will be like outside, always alone. Okay, kind of that. So those values which is not, maybe due to some human made mistake, or the nature of the data, where it will be unusual data from your regular data. For a simple example, and this is going to impact your data analysis pretty much. For example, take 1 to 5 numbers and calculate the mean of that. This is your data, 1 to 5. What is the mean? 1, 2, 3.
2.5.
That is your mean. Now consider whether by mistake or by chance you got another data that is 50. So now you have 6 data, 1, 2, 3, 4, 5, and 50. Okay. Now this 50 is going to act as an outlier for you, and this is going to impact. What is the mean now? If I include 50 in my data set, 50 plus
50 plus 15.
50 plus 15 divided by 6.
6.
So this will be around like more than 25, right? More than 25.
Distance from the mean will be more.
12 point something.
So when you have 5 data, your mean was 2.5. Now by mistakenly someone added 50 here. Now your mean is 25. The central tendency changing drastically, right? So suppose you are analyzing any business impact here and you got some outlier. Your analysis will be sky high, right? And your analysis and prediction will be impacted pretty much. So that's why outlier is a problematic thing in machine learning and the data analysis. We have to get rid of these outliers. Okay, that is the first thing. And this box plots and the EDA techniques, exploratory data analysis techniques.
Sir, is it outlier? Outlier.
And that English also, I also sometimes I'm not able to hear this sound.
No, layer, L-A-Y-E-R, L-I.
See my screen here. L-I-E-R.
Oh, liar.
Okay, so pronunciation you can hear from here, right? Okay. So here the pronunciation how it is, like outlier, like that it is saying outlier. Okay, so this outlier, and guys, if this, there is a dedicated session for this. Okay, this is really important to handle the outliers first. A very important thing in data science and machine learning, removing the outliers and all. Okay, and we'll see using the box plot.
Ashish, sorry to cut you off. Like, can you please, go through once the IQR interquartile range? I think I'm missing somewhere.
Best way to go for image, right?
Okay.
Now here, let me see which figure will help you out more. This one will be with right. Why it is not getting loaded? Wikipedia. What is happening to it? Okay, loading. Now can you see this figure? See this IQR and all, we have the session, particular session for this one. Okay, where you will calculate the IQR range of your data and find the outlier. You need not to worry about that. Okay, just you see here. Q1, Q3. Is it clear, guys? First standard deviation, second standard deviation. So Q1 means, see guys, see here. Dinesh, this one, can you see this part? IQR range is this one. Quartile 1 to quartile 3.
Okay, so how do we know that, like, from Q1 to Q3, that is the IQR range? Like, how can we specify that, like, from minus like
25th? See, 25th percentile is Q1 and 75 percentile is Q3. So you calculate.
That's what I'm asking. Like, how we were describing that from 21 to 25. How can we?
Quartile 1 is falling under 25th percentile. Like if you'll what we mean by quarter.
Okay. Fine.
That concept. Q1, Q3. Quarter means 1/4 of something, right? Like you divide something like 100 means 40, 25, 25, 25, you made 4 quarters, right?
Yeah, yeah.
That means first quarter to third quarter data. That's what it
Okay,
is like.
okay. Then it
It's
is fine.
called, yeah. And also we'll see how to calculate this one. This is the formula to find the, I think Silpa is aware about it. This is the formula to find out the outlier here. Okay, we'll see that. There is a dedicated session for this one to handle outliers, how to find this. Everything is there. So the point is here to discuss about box plot. It is helping you to find the IQR, also the mean value, also the minimum maximum value, also the outlier detection. So many things is going to help you out. Okay, that is the point here. Now, let me clear. This is not getting cleared, right? Okay, box plot. Now, let's see something called violin plot. I'll show you this first, then I'll discuss you what is happening. Okay, right. Okay, this is called a violin plot.
Our data is dependent on this plot, or analysis is dependent on this graph, or like the program.
So
graph?
Using your data, you are going to plot this graphs. Suppose you have a data frame and there is a column called age column, right? And you are plotting that particular age column in a graph. So this data means, suppose you have a data frame which contains 10 columns. One of the column is the age column or income column or any numerical column. If we'll plot that column, particular column data, this is going to tell you about that particular column.
So this is nothing but the visualization part of our analysis.
Correct. Yeah, our own data. This is the visualization part of our own data. This is called EDA, exploratory data analysis. Okay, and this is also one type of plot called violin plot. If you look it carefully, I'll come to the data part. From where? Okay, before that, let me tell you one thing, guys. See.
Sir, sorry. The box plot is only for one column, is it? Not for the entire data range.
Yes, one column. Like when I say data, what does that mean? When we say data, that means what? We are having a data frame as a data. I mean, just for example, I'm saying, okay, the easiest way is to get a data frame. Now the data frame contains multiple columns. That is called your what? Features. In data science, in machine learning, the columns are called, I told you, right? Interchangeably, this name will come. Features, independent variables, dimensions, columns, right? So these are the different name of the columns, right? So this is called features. Each column is one feature. Now in exploratory data analysis, you are going to analyze each of your column, each feature of your data, like this. Okay, that is
so using box plot, we analyze the data of each column.
Each column, correct. And that you need to do, and this is not done actually. That is like after this whole session, you will get understanding what you are going to use. There is a concept of univariate analysis and bivariate analysis. What does that mean? I'll tell you. Okay, let me tell this one to you. Univariate analysis means when you take one column from your data set and then analyzing or plotting this graphs, one feature or one column. That is called univariate analysis. When you take two columns and analyze, that means what? X-axis one column, Y-axis another column. Are you getting what I'm saying here? This is called bivariate analysis. That from your whole data frame, you are taking two columns and plotting the graphs. We'll see what is the bivariate graphs we are going to see in the next few minutes. Okay, so this box plot, violin plot, are what? Your univariate analysis. That means using one feature from your data set, you are going to analyze the data. Making sense? or any query? Okay,
And
so
excuse me, sir. We have here we have see histogram, that violin and box plot we have seen. When we all the three of we have used only one column to analyze the data.
correct.
When should we use violin? When should we use histogram?
Everything you have to use. So whatever knowledge you have to apply, because when you have some unknown data from your work environment, your job is to try everything possible and get some outcome, right? So it will be better that if we'll plot everything and try to see, because see, histogram and box plot, what is the difference between them? You tell me. You understood histogram, you understood box plot. Now what is the difference? Is there any difference or not, or this is like same thing? Try guys.
In box plot we have calculating the interquartile range, and you told me that that outliers we can easily able to know using box plot. But
yeah.
But I don't know any difference between the histogram and the box plot. Histogram also it's showing the continuous results from the x-axis to y-axis. It also shows the values to the here that values. I don't know. I don't know how to get different from both these.
No, you know so much things now. Okay, so that no worries that you don't know. You already answered all these questions. Okay, knowingly or unknowingly, but you already answered. The main point is here. If you can see here, only one thing is like you have a clear understanding of your mean and max value from your data. From histogram also you can tell the mean. From box plot also you can tell the mean. Agree?
Yes, sir.
Okay, but from the histogram you can't tell the IQR immediately without calculating, but here you can say that, right?
Yes, sir.
But here, can we know the distribution of a data, whether it is taking bell-shaped curve or any kind of distribution? Know that this one you can't say here, right?
Yes, sir.
Okay, so these are the difference. So you understand this difference, and you try to think what you need to use. Now, what is violin plot? Like the discussion we are just now having, that is the answer is in violin plot. Why? Because violin plot is not in your course, guys. I am showing this like what I know. I thought to pass to you, okay, rather than going, because this is something more thing. So violin plot is not there, but violin plot is the combination of histogram and box plot. Okay, that's why this is really interesting here. That if you see here, okay, let me first explain this violin plot. I'll come to the data part, don't worry. Can you see why it is combination of box plot and histogram? This part.
Right, we have a box and out is a
okay, this is red colors, right? So see guys, the middle part of this curves is box plot. Can you now identify? Isn't it box plot, the middle part here? And this square is the IQR. Okay, and these are the histogram of the data. You can see the bell-shaped curve. Both the side, same thing, both the side. These are the histogram, and in the middle part it is. So in one plot, you are seeing the distribution of your data. Also, what? The box plot. Okay, and this middle white part is what? Mean. So in a single plot, you are getting the distribution along with the box plot information, IQR information, mean information. So this is the combination of what? Histogram and box plot, the violin plot. So that means you told when to use what. Now you understood what to use. Directly use this one.
Yeah,
instead of
Thank you.
Instead of using histogram and box plot. But you can, for practice purpose, you have to plot everything. Once you have some expertise, you can decide without looking it. Okay, I'll try with this one and I'll see. Okay, but as this is starting point, you please practice with every curve or plot that you have. Right now, let's come to the data part. How this data I drawn here. Okay, First of all, there is a very good library. I told you this is C1, right? So in C1, for the learners, those who are learning recently and they want some data with us, immediate data to explore the plotting and all. Like some data we need to plot the things, right? So the problem is we don't have the data in hand right now. This library is providing some features here. They are providing already uploaded data set. Okay, and each data set is having their own significance in terms of business problem. So I think we have some around this many data set, already present data set. Now, though few of them you are already aware, I think this Titanic data set, house price prediction is not here, but yeah, Titanic one is so there are few famous data set, guys. Okay, that is in the market. Those who are starting data science, they would be aware about this, like Titanic, your house price prediction. Okay, and your iris data set. This is iris data set. Iris data set is nothing but the information about 3 flowers. Okay, iris data set 3. Let me show you this. What is this iris data set? Let me show you the pictures. I was expecting the flower pictures, but it is showing me the EDA. See guys, this is the EDA work. Okay, we'll come to this one. Okay, this is called bivariate analysis. When you took 2 features from your data set and start not why my internet is too slow today. I'm not sure whether it is my internet or guys, just let me quickly change my network. 1 second. Oh, I'm connecting to a different network today. That's why I'm saying why it is very slow. Just 1 second, guys. Give me 1 second. Let me connect to a good network. Too slow today. Okay. Maybe I'll getting disconnected for 2 seconds. Just 1 minute. Right, now I'm back. Okay. Your internet connection is not. Guys, am I audible or my voice is breaking in between?
No, you're audible.
Then it is why it is saying I'm unstable.
Sometimes it
sometimes happens. Yeah. So iris, flower. So I just wanted to show you that flower and how these things are going on, but it seems like it is the issue with my network today. I'm not able to get the okay. Notice. So every data set, every name of the data set has their own significance and own business problem. So this is solving what you are going to create a model which will based on the flowers dimension. Okay, flowers dimension. It is going to predict the species of the flower. Okay, this data set is called iris data set. Like this, every data set has their own significance. You can Google it and find out the data, related to data set. But the point is here, you need not to download this data. Okay, you need not to have a CSV file or download to this data in your system. Instead of that, you just call this library C1 and call this function called load dataset. sns.load dataset and give the name of the dataset. That's all. The dataset. So see here, there is a dataset called tips. This dataset is based on the hotel timing and the tips and the billing of the hotel. One hotel's billing information. There's a data set. So we are going to add the tips data set here. Let me run this one. See, I didn't input any data or any CSV file, but still I got a data frame. And this is called what? Tips data frame. Tips data set. Here you have how many columns? 1, 2, 3, 4, 5, 6, 7. 7 columns and 244 rows. So this kind of data is going to help you out with a quick analysis. You need not to load any specific data. Okay, if I'll change it to iris, okay, this will be my iris data set. See, sepal length, sepal width. This is the dimension of the flower, length and width, petal length, petal width, and this is the class of the data. Setosa, Virginica, versicolor, 3 classes are there. 150 rows and 5 columns. So we have how many data set like this? This many. Okay, so you can load any kind of data and understand the business problem and start doing your practice of EDA. You are getting right? So this violin plot I plotted against tips data set. So what is tips data set? Total bill, the tip amount paid by the customer, the gender of the customer, whether smoker or not, which day he paid or he visited the hotel, time, dinner or lunch, okay, how many customers are there, like this. Okay, small data set to analyze. Here how I'm going to plot the violin plot here. If you can see here, I load the data set, this data set, then I'm calling cborn.violin, violin plot, cborn.violin plot. Here can you see? Okay, to make you understand about this, I have to still I'm not happy with my internet today. Okay, no worries, that happens, right? So
one like violin plot and C1 only, or when matplotlib also?
it is there in matplotlib. Matplotlib, I'm not sure. Hold on a second. To check quickly, plt dot violin. It's there. It's there. So I told you, right? I draw it with using one library. You try to draw with another library, right? See, matplotlib is violin plot also there. But here the what parameter you have to understand, okay? Okay, so let me explain with C1. You do it in matplotlib, right? Now, if you see here, C1 violin plot, what are the parameters? This many parameters, okay? This many parameters. First parameter is the data. What is data here? It is a data frame or array or list of arrays. These 3 types you are going to pass as data. Either you can pass a data frame or array or list of arrays. What is X, Y, and U? X means which part you are going to plot in x-axis. This, right? Y-axis is this one. Simple, right? Simple. Now, if you see here, can you tell me what I given as x equal to day, where this day came from? And y equal
from the data frame.
From the data frame. Because if you see here, I already passed the data parameter I was talking about, right? Data parameter. Here I already passed what I passed? The data frame. Data equal to your what? Data frame. Here my data frame is the tips, right? So just 1 second. Why it is taking tips? Oh, okay, sorry. Here I am defined tips, right? Okay, guys, this is my data frame and I pass in the data parameter. X is the day column of this data frame, Y is the total bill. And this is how it got plot. Now tell me, what is your analysis here? In the day, we have what? All the day count. Thursday, Friday, Saturday. In the total bill, Thursday, what is the total bill? What is the mean value of the total bill? Okay, what is the IQR of the total bill on Thursday? On Friday also you can say, Saturday also you can say, Sunday you can also say. Now there is another parameter here called hue. He, or what is this called pronunciation? I am also not very sure. HUE. Okay, this is a very important one here. It is going to help you. So what does this mean? Can you see what column I passed in the HUE section? The gender information, right? So you will do one thing, it will separate out the different categories. That means it will go to this column, sex column, and it will find out how many categories are there. How many categories are there? 2, female and male. And it will separate out with different color. That means if you are going to plot the data, it will get one color for male, one color for female, so that your understanding will be better. This is what it looks like. If we'll, so see guys, the same code here, only I used what? Now can you see, because of this hue, it divided into 2 categories, male and female. And in the left hand side of the data, it is the male. That means what? What is the analysis here? Thursday, this is the distribution from male, right? Total bill information of male. And this is, right hand side is the female. Like this, you can also divide your analysis into different categories. Making sense, right guys? Any question on this? So violin plot is, try it out, okay? Try it out on your own and try it in your project. Simple X and Y coordinate I have. How to draw the graph here, guys? Simple X and Y coordinate I have. Using matplotlib's plot function, where you provide X and Y. Can you guys tell me if this X length and Y length should be similar, or it is not necessary? Length of X and Y
Should be similar. Then only we can.
Not necessary, sir, I think.
Not necessary. Okay. And to prove this, what we are going to do? Let's introduce another point here, right? What is that? 6. And let's see. Let's try to plot it. What is the error getting? Value error. X and Y must have same first dimension, but have steps of 6 and steps of 5. Are you getting? So the message is itself clear. So that means the length should be same, or else you are not. See guys, consider you are plotting this curve. How you are going to plot if you don't have another Y point of this X? How to plot it? Think about it. So that means the length should be equal, right? Pie chart.
Okay, sir.
Yeah, pie chart. Pie chart we all have seen, right? You guys already, are you guys using pie chart in your analysis in your work environment? I think in Excel also we can draw pie chart, is it?
Yeah.
And remember something, yeah. So pie chart, this pivot table. So those things now you can, using this also you can do. Now this is a simple example of pie chart. I want to show you. So why we use pie chart? To show the distribution as a whole. Like suppose 100% is there. What is the percentage of this category? What is this category? So on a whole, what is the percentage of individual component? In that case, we use pie chart, right? Or any other cases you guys are using? No, right?
Yeah, probably that's the case. Like to show the difference between the categories and how much it was occupying in 100%.
Right. So matplotlib.py, then size, then the labels. What is this labels? This is nothing but, that means you plot it, you plot this data in a pie chart, and those area which is coming under 30, you label them as apple. Which is coming under 40, you label this as bananas, like that. Just to show you one example. Now, can you do this with C1? Can you try to plot this with C1?
Sure, Ashish. This data was
tell me-
available in that already, right?
Sorry, C1?
This data was already available in that, right? I'm asking. Okay.
Yes,
C1,
it's already available in that. Or do one thing, open ChatGPT and search a sample code to plot a pie chart in C1. I think that will be quickest way. So in pie chart, you will get in C1 or Plotly, you will get one more visually interactive graph. So C1 pie chart. Okay, C1, can we mix? Excuse me, guys. So, what is C1 official site? I'm not to find the C1 official site. There is a C pie chart in C1 or not?
Most probably no, Ashish, because when I tried to do that, it's giving me an error. That module C1 has no attribute as pi.
Maybe that is something different name. That's why we need to explore the documentation. Yes, I think C1 pie chart is in pandas also, guys. See, this is a new thing. In pandas data frame also, you can plot the pie chart using directly. You can, from your data frame, you can directly, you need not to extract the data separately, right? So see, guys, this one here, PD data frame. Okay, df dot plot dot pi, then y equal to mass and figure size. Okay, great. So using data frame also you can plot this, guys. See, pie chart you can plot using directly calling your data frame. You can, and that. So anything you got from Chat GPT? Those were
Seaburn don't have a pie chart, it seems. Yeah,
right.
It says apologies that Seaburn don't have by default a built-in function for creating a pie chart. Seaburn is primarily focused on statistical visualization, provides a high-level interface for creating in various type of plots such as bar plot, line plot, scatter plot, like that.
Great. Right. See, but I got something from pandas data frame. So this is my what is happening? This is my
You can't able to select, right?
What is happening? Something is happening. Maybe I need to restart my laptop, but I'll do.
Oh,
okay.
Fine. I just like you just.
Okay. So data frame. This is the data frame. I just wanted to show you the data frame, but not able to.
Yeah,
copy
you can annotate, right? Then it will be easy.
So if you see here how this is getting plotted, actually, that it is calling the data frame that you created, then plot attribute, then pi, and here in y you are going to give the mass. So mass, and so tell me what is the column of this data frame? What are the columns? So that's why
Mass and radius are the columns, and using mass column, it is plotting a pie chart.
Mass and radius are the columns, and
using mass column, it is plotting a pie chart.
Using mass column, it is, and how this this indexes are coming, the labels.
It's plotting for mercury, the mass is 0.330.
Okay. Select. Okay, so I'm not able to copy. Okay, no worries, guys. Can you try in your notebook and see? Okay, explore this one. So the point is using Mars, Mercury, Venus. These are the 3 rows. Correct me if I'm wrong. Okay, these are the Mars, Mercury, and Venus. Sorry, Mercury, Venus, and Earth are the 3 rows of your data frame. Mass and radius are the columns of your data frame. Okay, and using mass, you are going plotting pie chart, and this is the mass of what? Mercury, Venus, and Earth. Okay, this is also a pie. The point is, using data frame, you can directly call. Using matplotlib, you are call plotly pie chart is there. Okay, we'll see plotly. Okay, I don't want you guys to check now, but check later after the session using plotly. Ask ChatGPT to using plotly. Okay, here donut chart is kind of what? Cousin of this pie chart. Cousin in the sense like not cousin, you can see the same method pie. But here you need to if you see here,
Ashish, sorry to cut you off. Like in matplotlib, like we can just use plot.py, then it will be fine, right? Like plt, whatever the variable we were using. Like if you want to call any kind of a chart, like we are supposed to use the variable which we use to import, and then we can use like pi like that.
Right.
Okay.
Right. So I just wanted to show you whether this is working or not. Okay. PLT, same thing. For donut chart, same. But here I am giving radius equal to 1. What is this radius? This radius is what? This one, this radius of this circle. Okay, and if you want to change it, suppose I will change it to 0.5. That means what? Radius is I'm making it half. Can you see what is happening? The radius is getting decreased.
Yeah, the size
is getting decreased. Okay, let's put back to 1. This is radius. Okay, and what is this Weight-Gauge property? Weight-Gauge property. Weight-Gauge properties means what? This, if you see here, inside weight-Gauge property, what I put it? Width equal to 1 and H color equal to R, and I pass this in a dictionary. And why I pass this in a dictionary?
Keyword argument.
Right. To find the answer, you have to go here. Right. To find this answer, you have to go here. Here, X labels we saw. What is the property we are discussing? Weight-Gauge property. Here, this one. This is either a dict. It means what? Dictionary. Dictionary of arguments passed to each patches.Weight-Gauge of pi. For example, Weight-Gauge property line weight 3 sets the width of the Weight-Gauge broad line equal to 3. By default, this means what? You are passing this. So can you see whether I pass this in the same manner here? What is written here and what I am passing here, is it same or different? So guys, like writing like this, what? A equal to 3. Right? This is dictionary.
Yeah.
And writing like this.
There's also a dictionary.
So let's print out. Why invalid? Oh, okay. Same, right? Please verify this one. First, I gave the sign and put all these things. This is same. Here I mentioned the type, dictionary type, and inside that I pass a equal to 3. That means what? This becomes my key. This becomes my value. Understood, right? This is same thing is happening here. I am passing this information in form of a dictionary as mentioned in the documentation, isn't it? Line width 3. Hope you guys are clear, right? So that means what? Width equal to 1. Now width equal to, I'll make it to 2. What will happen? What is this width? Not 2, man. This is like, let's make it 5. See guys, this width of donut. Can you see if I increasing the width, why 4 colors are coming up? If I'm making it to 2, what is happening? It's like, it's kind of, twitching to each other. Like if you see here, it's like cross over each other, the donut. If you fold the donut, imagine you're folding the donut. Same thing is happening here by making width equal to 2. But making width equal to 0.3, that means what? So this width is what, guys?
It's the width of the donut.
Right. And this edge color means what? The border, the perimeter color and the borders which is separating the classes. That is red. If I'll make it green, so G. Suppose I'm not sure G means they have green. Well, yeah, it is green, right? Can you see here? Borders and the perimeter of this circle. Now tell me, this inner circle is being, which parameter is being decided by this inner circle? If I want to
Radius 1.
So what I need to change here? If I decrease this inner circle radius, shall I decrease this one?
0.5.
Suppose I want to increase this width of this donut.
Wedge property.
Width, right?
Yeah.
Okay. Super clumsy now. 0.4. I think with radius 0.8 it will work. Yes. So now you got what is happening inside, right? So from these properties, right? And if you want to explore more on this, please refer that documentation, because there is too many parameters here, right? Counter clock, strangle, text properties, so many things are there. So based on your requirement, you can identify which one you are going to use. Now this one is a stacked bar plot. This you need to pay attention a bit, okay? This is here, you can easily get confused here, but yeah, but easiest one. If you understand, it will be very cool, right? So if you, what is a bar plot first? We have all seen bar plot. What is a bar plot and when we use bar plot? I guess you guys are already using in your work.
To know the statistics, which level it went down, which level it went high, which level it went medium, that kind of stuffs we can see it with a bar chart, like.
That means the count of something, right?
Yeah, the count of something.
Now what is a stacked bar plot? Okay, first let me show you how a stacked bar plot looks like, then we'll come to the coding part. This is how. So if you see here, I have 3 groups. Okay, group 1, group 2, group 3, and inside each group I have subgroups. Subgroup 1, subgroup 2, subgroup 3. Now using stack bar plot, I am going to show you what is the distribution of each subgroup in each group. Making sense? That means what? instead of plotting it separately, we are plotting inside the same plot and identifying the proportions of the subgroups in each group. Now you understood what this plot is now, or any query? Let's try to see the code here, how I plotted that. I'll come to this course. Okay, this is the explanation of this code only. Okay, so first of all, you see I created a list which contains my groups. I created a list which contains my subgroups. Now tell me, which should I put in x-axis, groups or subgroups? You
Groups,
saw the
right?
graph, right?
Groups we put. Yeah.
Okay. Okay, let me show you the graph again. In the x-axis, what do you have? Group 1, group 2, group 3. And in the y-axis, what I have? The
Subgroups.
values of the subgroups. Right. So why I'm telling this to you? Because you have to decide beforehand, before plotting the curve, stack bar plot, what you need in. So you know your domain, you know your data, which part you need to plot in x-axis and which part you need to plot in y-axis. That you need to decide first. Right. That I decided here. Now this is my data. To know the data, I did some postmortem here. Tell me, what is the shape of my data here?
Bar.
Sorry.
3 by 3.
No, not that. Okay, not that shape. The number of rows and columns. That's it.
3 cross 3.
Yeah.
So this attribute will tell you what?
Number of rows and columns.
Right. This is the quickest way to know how many rows and how many columns you have in your data set, right? So 3 rows and 3 columns we have. Okay, and this is what my data looks like. Now, if you see 100, how many elements are there here? 3 rows, 3 columns. This is 1 row. This is 1 row. This is 1 row. Agree? And this 100, 200, 300 is 1 column. 20, 30, 40 is 1 column, like that. Now, this 1 row is my 1 group. This 1 row is my 1 group. That means, what is my group 2 data here?
Second row.
Okay, and that means row means group information here. Column means subgroup
Columns are
information. Subgroup information here, right? Subgroup information here. So 100, 200, 300 is what? Subgroup of what? How to explain this? 100. Suppose someone asks, what is 100, 200, 300 in your data set? This is the subgroup in subgroup 1 information. Subgroup 1 information in group 1, group 2, and group 3. Am I correct to say that? This is the subgroup information of group 1, group 2. This is the subgroup 1 information. And this 20, 30, 40 is the subgroup 2 information in group 1, group 2, and group 3. So why I am explaining this thing to you? Because this is the first step you need to do when you are going to plot the stacked bar plot. You have to understand your data.
So that 100, 20, 30 is all the data of subgroup 1, and 200, 30, 40 is the data of subgroup 2, and so on.
No,
right?
no. It's the opposite. That's what you said. When I say opposite, what does that mean?
Yeah, 100, 200, 300
is the subgroup 1 data.
Okay.
Subgroup 1 data, but it is, so this 1 row means 1 group. How many groups we have? 3 groups.
Yeah.
Group 1, group 2, group 3. So each row is, this is group 1, this is group 2, this is group 3. 100, 200, 300 is subgroup 1 information. Subgroup 1 information in group 1, group 2, group 3. Okay. Let me show you the graph here. That will be more. See guys, group 1, group 2, group 3. Each row is group 1, group 2, group 3. Okay. 100, 200, 300 is the subgroup information in group 1, group 2, group 3. That means which one 100, which one 200, which is 300, which part?
Up
When I
to
say subgroup 1, that means which color? Blue color. Can you now see 100, 200, 300. Subgroup 1 information in group 1, group 2 and group 3. 100 in group 1, 200 in group 2, 300 in group 3. Which one? The blue color. That is subgroup 1. Making sense here? 100, 200, 300. What is 100, 200, 300? What is 100, 20, 30? So this 100, 20, 30 is what? The information about which group?
group 1.
Group 1.
Group 1 and all the subgroups. 100, 20, 30. 100 is blue, 20 is the red, 30 is the green. Not red, it is orange, right? Tell me, you understood the data now before I jump to the code now? Or any difficulty to understand? Because this is what you need to do first if you are going for the star bar plot.
Yeah, still it is confusing for me, Ashish.
Okay, so you think how you can, remove your confusion here. What is confusing you? Tell me. Then we can go.
We have the data, right? Like 100, 20,
We have the
30.
data.
So yeah, that is group 1. And then like if 100, 20, 30 is a group 1, like it will work in that way. You're saying, right? 100, 20, 30. These things where are the groups, and then 100, 200, 300. These all are the subgroup 1 data. So it was grouped with subgroup 1 data, subgroup 2 data, subgroup
Yeah,
3 data.
yeah.
This whole become in group 1, right?
Which whole become? This whole is group 1. You told correctly. The last line I'm just saying. You completely you are now. So the thing is like you are getting it. Okay. So immediately it will not come, but yeah, it will spend some time and think. So you explained it correctly.
Okay. Now I'm fine.
Okay. So now let's jump into the code. Okay. Let's try to understand the code. Then it will. So now tell me how to access the row, the specific columns in this data set. The concept is from our slicing, array slicing, list slicing, how to access one particular column here. Suppose I want to extract first column information. What is the first column information?
100, 200, 300.
300. How to extract that?
Data 0.
Data 0 will extract, you mean to say data 0 will extract 100, 200. Okay, let's see that. What it extracted?
No.
Okay. So first, so we can give a comma and then a colon over here. No.
Okay. I'll tell you.
Colon and then a comma and then a 0.
Right. So you guys are like remember, right? Great, nice. So this is how you can access a particular column, and this is how you can access a particular row. This is the first column. This is the first row. Making sense? Now, why I did this? Because we are going to use this concept. If you don't understand here in the code, you are going to face difficulties. Now so this is what you need to do. You understand your data like this first. Okay, what you need to put in x-axis, what will be your subgroup, what will be your group, that you decide beforehand, before writing the code. Now let's jump to the code here. This is, we all know, right? This is the data. And subplots. I told you before, right? Plot dot subplots. When we use this? When we have multiple subplots to be plotted inside one single plot, isn't it? And this function is returning me two things, figure and axis. Anything you want to do with the figure size, figure dimensions to change with this, you use fig one here. Anything to do with the axis name, axis unit, axis number that you are going to put inside the axis, those you can do with AX. Here you are going to plot the bar using this AX, axis dot bar. So this is not stacked bar. This is the normal bar, just the normal bar. And to know about this, again, what you need to do. So let's not go to the documentation. It is clear here. This is x-axis. This is y-axis. That's all. So what I need to put here in the x-axis, that means what? Group 1, group 2, group 3. What is in the y-axis, guys? So in the x-axis, I have to put the group information.
Yeah.
What do I need to put in the y-axis? The subgroup information.
Subgroups, yeah.
But here, can you see in the y-axis which part I am just extracting? First column of my data. First column means what?
100, 200, 300.
Tell me this length of this and length of this. That is the only answer I need. Length
3
of
cross
group.
3.
Right.
Sorry,
Group
one group. Yeah, one group and.
Length of what, Ashish? Can you repeat?
Length of. Sorry. Please continue. What was someone saying?
I'm just saying, what did you ask? The length of what?
Length of x. What I passed in the x. What I
X.
passed in the y. In this line. I'll comment out this 2 line. It's something with my mouse, it seems. Not a problem. Huh? So this part.
X would be 3. The length of X would be 3. Group 1, group 2, group.
Okay.
And the
Correct.
second one would be an array of size, all the rows, 3 cross 1.
So what is the length then? So this is nothing but this one, right?
Yes.
Same, right?
Yes.
How many elements are there in this array?
3.
So the question is, I show you the plot here, right? I changed the number of here we saw, right? The x and y should be same length, or else it will be difficult for you to plot it, isn't it? We saw here, right? So that means what? This x and y data, the length of the data is same. That means 3 items I am passing in x. That is what? Group 1, group 2, group 3. And 3 items I am passing in y. What is the value of this? 100, 200, and 300. Okay, so let me show you. I'll come to this code. Okay, I commented out, and the label is what? The label is the subgroup information, and here the title, x-axis name, and all. So this is what the first plot. I commented out these 2 lines only. With this line, I plotted a bar plot where in the x position I provided groups, in the y position I provided the first column, that is the subgroup information. Can you now verify whether this data is correct?
Yeah.
100, 200, 300, the blue color. Remember the original graph, right? We are seeing the blue color means subgroup 1. And in each group, what is the distribution of subgroup 1? 100, 200, and 300. So this is a normal bar plot. This is not stacked bar plot. We are going to create the stacked bar plot by plotting the subgroup 2 information above to this bar. That's why it is called stacked, right? One top of another. So blue is subgroup 1. We are going to stack the subgroup 2 on top of it. How to stack the subgroup 2? Tell me how to get the, what is the subgroup 2 information? What is the subgroup 2 data from this my whole data? What is
20, 30, 40.
30, 40.
Correct. That means what I need to do here? 1. 20, 30, 40. Now my x-axis is same, right? Group 1, group 2, 3, group 3, right? In the second line of code, this line
And
of code,
Ashish, like in here you have given labels, right? Like subgroups 0, 1, 2, 3. That is a is that a predefined or it's a user defined?
So this is my subgroup information. List of what?
Okay.
Subgroup.
So you are
Okay.
You are accessing through
accessing
indexing.
subgroups. Yeah, correct. And this blue color is subgroup 1, right? That's why I'm labeling means what? This label is coming. This one is coming off because of that one, right?
Okay. So instead of writing subgroup 1 in here, you're just mentioning the subgroups there,
correct.
and then you're accessing via indexing. Get
right.
it?
Exactly. So this is subgroup 1. Let's go for subgroup 2. Now label will be subgroup 2 will be in this list, second element, This one you understood? It was 0 here, it was 1 here. That means what? Label is subgroup 2. Now subgroup 2 data is here. X-axis is same. Here only difference is there is a parameter called bottom. Bottom means the graph you are drawing. This is the bar you are drawing. Which bar? For subgroup 2. What is to the bottom of this subgroup 2? What is the bottom of the subgroup 2? That means bottom of the subgroup 2 is subgroup 1, because on top of subgroup 1 you are going to plot it. That's why bottom means which data is below to this bar. Which data is below to this bar? Subgroup 1. And that's why I mentioned what? Data colon 0. That means what? Blue color data is bottom to this new bar that we are going to create it. Now let's plot it. Can you see?
Excuse me,
This is
sir.
the sub. Yeah.
We have 3 groups, right? In group 1, we have 100, 20, and 30. In the graph, we are showing, it shows 100, 200, and 300. That is the subgroup value. We have not seen the group 1 values 20 and 30. That second and third value.
Correct, Divya. So you got the right spot here. Okay, you got the right spot. But we are building that. We have not completed the group 1 data yet. We are just stacking and building it. First, we gave subgroup 1 data. Then we are stacking subgroup 2 data on top of it. Then we'll do the subgroup 3. Then you can see this 10, 20, 30, what you saw told right now, right? This 100, 20, 30. Now, till now, what we did? 100 and 20 we built. Okay, in the group 1. For every group, we only build the subgroup 1, subgroup 2. And we are stacking it. We are stacking one by one. Okay, so that's why I'm commenting this codes and showing to you. So this 2 is what? Plotting 2 subgroups. Now if you see third line, same thing, everything is same. Only in the y-axis, this is subgroup 3 information. I need not to explain this one now. In the bottom of this, the new bar that you are going to plot, that is subgroup 3 information. What is bottom to this graph? Subgroup 1 plus subgroup 2. Are you getting it? So if I will run this code now, what will happen? Subgroup 3, that is in green color, is being created. And in the bottom of this code, what we wrote? Bottom to this green color, there is blue color plus orange color. So this you need to mention. What is bottom to this one group? Now this is your complete graph. Group 1, 3 subgroups, 100, 20 or 30, whatever the value was. Group 2, it is 200, then 40, then 50, whatever the value is. Group 3, so this is how you are building what? A sample stacked bar plot. Now tell me, if I have fourth group, fourth subgroup, what is the code here I need to write?
X bar group data semicolon comma 3 bottom equal to data. Then we have
0,
to write semicolon.
1, 2.
Yeah, 0, 1, 2.
1.
Yeah.
So this plus this data
again
in the next line, right? So if I have another subgroup information, here the modification is 3. And here you have to pass another. So that means what? The subgroup's bottom is what?
Changing. You need to remove one plus there.
Plus sign. Okay. So that means below to this subgroup, and here you need to change it to 3.
4.
Right?
Sorry, 3.
Below to this subgroup, what is the bottom two of it? Blue color, orange color, green color. That data you need to submit like this. Plus. Now there is a fundamental question. If I have hundreds of subgroups, what I will do? I'll write hundreds lines of code. For loop. Right? So in that case, we'll see for loop. Okay. Actually, this is a simple one. So there is a concept of relative stacked bar plot. This is just a simple stacked bar plot where you're stacking on top of each other based on the values. Now, any query to understand this one, or it is clear? I'm going to remove this line. Sample stacked bar plot and relative stacked bar plot. The relative stacked bar plot is bit different here. Same thing. I'll let me connect and show you the output here. This is the output. Okay. Relative bar plot. Can you see any difference here?
Y-axis.
Y-axis. Okay. So there's a bit understanding here. This is it is always recommended to use the relative star bar plot instead of the simple bar plot that we saw. We'll see what is the difference. A relative stacked bar plot is a type of visualization used to compare the proportion of different categories. Here, proportions. What does that mean?
Percentage.
Right. Correct. So instead of the value, instead of the raw value, you calculate the percentage or proportion of that subgroup. Then now this has some significance or this has some benefit. Okay, we'll see that benefit also. And why I have created this 2000, 3000 guys. Let me change it. I'm not sure. I changed it based on some. Okay, we'll see that. Okay, we'll see that. Now I will. There's definitely something wrong with my laptop today. I have to restart it. Not able to select it. Okay. Oh, it is getting selected actually. Okay. So guys, can you see this is my data? I didn't come to this part. Okay, this is my data. Same data. 100, 200, 300. This is what? Group 1. This is what? Group 2. This is what? Group 3. Categories I have given was A, B, C, and groups as group 1, group 2, group C. Can you tell me group, what does this mean? That means group 1 contains 3 categories, A, B, C. Group 2 also contains 3 categories, A, B, C. And here the difference is we are going to calculate the proportion or the percentage or the fraction of data present with respect to each group.
The category is nothing but like the subgroups that we had seen earlier.
Correct. Okay. Subgroups. So instead of subgroup 1, 2, 3, I wrote A, B, C. Okay. And here, how to calculate the percentage? This is my data divided by data sum into axis equal to 1. So I'll explain this parameter. First, you tell me how did this go? How this got calculated? How this value is 0.666? How this value is this? So tell me each part how this got calculated. When I
100 divided by 150 into 100.
100 divided by
150.
100 plus 20
plus 30.
plus 30. This is what you're saying, right? Okay, making sense. What is this? 51. It is. Oh, okay. Right? How this one got calculated?
20. In the numerator, you can change as 20.
Just 20, right? 20, then 100 plus 20 plus 30. Now this sum is getting applied in this direction. Why? Because of axis equal to 1. That means in the column direction. So this value is got calculated 20 divided by this one, right? Let's see how this value got calculated. Now, why we are doing this? What is the benefit of doing this? This is a proportion of what?
proportion of each category within that group.
Correct. So I told you initially, right? This is group 1. This is group 2. This is group 3. And this 100, 20, 30 is the proportion of each subgroup or categories. So by doing this, we are calculating the percentage or proportion of each group. So that is why we are doing this. I will show you. Okay. Because in our previous example plot, what we are taking this only this absolute values, right? But here what we are doing, this is also called normalization, right? We are normalizing our data. Why we do normalization? I told you in our that
The data within a given range.
right, the units will be same. Suppose you have a kilometer and centimeter information. Centimeter information will be larger values, isn't it? But the meaning will be same. So doing the normalization standardization will keep every data into 0 to 1 range. Tell me how this Silpa, you don't tell this part, how it got calculated. Someone please tell me. This part belongs to which one? 25. So 20, what is the proportion of 25? How that got calculated? What I need to write here? So that
Here
get
the
this
same
number.
thing, 25. You need to erase 20. Instead of 20, you have to write 25.
What do I need to change here?
You need to change 25. Like we were calculating the data for 25 now. So to check the proportion of that, we have to change 25
divided by then
300, 25, 20.
Right. Right. So this is 0.072. Right, guys? So now I'm not going to use this data. Instead of this, what I'm going to use? This one, this value. Initially, we had rest everything will be same. Only the logic change is what? Instead of this data, I'm going to use this data. Now, when you use your data like this is called your what? Relative data. Right? So if you see here, and one more thing. Axis equal to 1 you got, right?
Yes.
If I make axis equal to 0, what will happen?
It'll go like this 100,
Vertical.
220. Yeah.
That means this value will be 100 divided by 100 plus 200 plus 300.
Yeah.
But that will be not my proportion of each group, right? This is the subgroup data, right?
Yeah, proportion of subgroups.
Right. So I want the proportion in each group. So this direction containing my group. So when you are going to apply in your work environment, you understand which data or which direction in your group and which direction is your subgroup. Then you put axis equal to 1 or 0. Keep dimensions true is a very fundamental. If you will remove this one, or if you don't give this one, let's see what is happening. Okay, sorry, let's not do it here. Instead of that, let's do it here, and here I'm going to remove keep dimension equal to true. Can you see what happened to my data?
It was clumsy.
Yeah, but it also, if you see, the fraction is 2, 1. So this is summing of all the information. That means it is reducing the dimension. While performing this operation by keep dimension true, that means you are saying that I have 3 cross 3. You also give me 3 cross 3, performing some operation in this direction. Here, if you don't mention keep dimension equal to true, there is a possibility that it will reduce your dimensions.
Ashish, in this case, it would do like every time for the denominator sum, it is taking the first row. Like
first row.
Yeah, so it will be 200 divided by 150, 30 divided by 150, and like 300 divided by 150, like this.
Yes, that means when we say keep the dimension true, that means first go this direction, then change the dimension, right? This, that means here what we're doing, 100 divided by this plus, in the next line, it is automatically picking 200 divided by this plus, because of this keep dimension equal to true. If you don't do it, then this will be the numerator, sorry, this will be the denominator every time for every data. That's what I was saying, right, Silpa?
Yes, yes, sir.
So keep dimension true is a vital part here. If you don't use keep dimension, you are going to get this kind of data, and this is going to like more than 1, 2, and 3. Okay, so this is not correct. So this is my correct, keep dimension true. Okay, now you understood the postmortem of your data. Now, if you see here, rest everything is same, but I used a for loop here as we discussed. But before using the for loop, I calculated one bar, first bar, initial bar. Initial bar means what? That subgroup 1, that means category A. So if I'll comment out this and run this, subgroup 1 and category A. Okay, so initial bar I plotted. Then I wrote one for loop for I in range. Why I took 1 here? And what is this 1 is using in? So for I in range 1 to length of categories. Length of categories is what? A, B, C, right? 3. So this range will run from which to which? What
One.
number? 1 to?
1 to
That's it. 1 and 2.
3.
No, 1 and 2.
Right. This is kind of questions you are going to get in your coding round. Okay, that means this part of range is what? N minus 1, isn't it? In Python, indexing starts from 0, right? So if you range 1 to 3, that means what? 1 and 2. N minus 1 it will. So suppose someone will ask you, generate me a number between 1 to 100. What will you do? Simple question. This is a question. Okay, and I have encountered this question in enormous of interviews. Okay, guys. To be honest.
Inclusive or exclusive?
1 to 100. That is my question without using any library. This is a basic question you will get in a coding round. Generate me number without taking any help of any library from 1 to 100.
So range would be
List of number. Generate me a list of number between 1 to 100.
so
Or I equal to 1.
Using for loop.
is equals to
Guys, see, this is the answer.
List comprehension you can.
range.
This is the answer, guys. Simple and right.
100, right? Between 1 to 1.
List range 1 to 100. I generated in a list 1 to 100. Okay, this is a one-liner answer. Like I every time I encounter an interview previously, this is the first question they will ask. The list without taking any help of. Tell me another answer. Just a quick one. Okay, one-liner. You have to write it. Yeah, another question I'm asking. Write in one line from this list. Remove those numbers which are divisible by 3 and 5. So this is my list. This list is given to you. Now write code to remove all the numbers divisible by 3 and 5. in one line. So
List
this kind,
comprehension we can use, right?
right, exactly. Tell me, what is the list comprehension quickly so that we can
Okay.
save some time.
So
See guys, I for I in what? List if I percentage 3 not equal to 0 and I percentage 5 not equal to
0. List name is not defined. Print.
One liner. Just this. So if you start writing for loop, then go and then go, then they will say like, okay, this is still, this person is not that much. So can you see here? We removed all the numbers which is divisible by 3 and 5. Just one liner. Okay. So this type of thing you need to practice, guys. Okay. And we come here because of what? Yeah, because of this range one. Now you understood what is the range here?
Yeah,
1
and
to
2.
3. That means I will be 1 and I will be 2. Because I equal to 0, we already plotted. That's why I'm taking what? I equal starting from 1. And here, if you see what I wrote in the for loop, bar plot, x-axis data. In the y-axis data, what I'm using? So data percentage is the thing we calculated. Now here y place will be starting from 1. That means what? Bottom is, so this is my y, this is my x, this is my y. That is the, what is, which column? This means which column in the first iteration? Second column. First column is this one, right?
Okay.
Second column is this one when I equal to 1.
Yes.
And in the bottom parameter, that means bottom to this bar is the first column. That I store that information in what? In a variable called bottom. Initially, I was passing this directly here, right? In the previous example, but here I'm passing the variable. And why I'm doing that, we will see the difference here. Now this is done. This is the, in the first iteration, it plotted the second subgroup or the category B. Everyone agree with that? Now here I am incrementing the bottom here, because if you recollect just now, we are keep adding the column dot 0 plus data column dot 1, column comma 1. Like that, we need to keep adding. So here bottom plus equal to this means what? This means what? Guys, A plus equal to 1 means
Bottom
what?
equal to bottom plus this one. A equal to A plus 1.
Right. So bottom plus equal to this means what? Bottom equal to bottom plus this one.
Yes.
So in every iteration, this bottom variable is going to change and it will be keep adding the columns automatically rather than going plus this like that. Every iteration. You agree? So even if you have 100 categories, just this few lines and you are set. Okay, so let's run this one and let's see. Okay. Any query to understand this one? I know first it will be difficult, but yeah, again, please spend some time. Spend some time with this code. Implement in your work environment. Okay, do mistakes. Then will, because mistakes are like every time you're going to do mistakes. Okay, guys. Now, absolute bar plot or the previous one we saw and this one. What is the benefit? Can you see here? This is absolute or this is absolute, right? This is absolute. What is absolute here? This is one group. This is another group. This is another group. Now I didn't do that. What? That proportion calculation. That proportion calculation I didn't do. Okay. And one group is having this many. The data value is what? 2000, 3000, 1000. Now, can you see what is the problem here? Because other groups data are very small, isn't it? It is very small. So here the interpretation from this graph will be very difficult if the units of the groups are different, because these are small number, these are, so this is why we need to calculate what the percentage. Now, if we'll do the same thing here, what we did the same thing, this some data we changed, one group data we let's change and plot it in the this one. I think we did already did that. We already did that. So if you see here, 2000, 3000, 1000 is already inside my data. Like we plotted this one, normal stack bar plot. Okay, but relative stack bar plot, what we are doing, because of this data percentage calculation, this part is getting handled automatically. Okay, and this is what you are getting here. And this information is now properly, you can visualize and you can see, okay, in group 2, the category B is more. True? Although these two units, these are hundreds, these are thousands. Although the units are different, because of relative stack bar plot, you can compare each group data, although it has higher value. But if you don't go with relative stack bar, if you go with absolute stack bar without doing the proportion, what will happen? This will happen. You're not able to see the group 1 and groups information because of the higher value in group 2. Making sense? Benefits of using relative stack. This notes is for you guys. You have to read this. Okay, not now, but after the session. Comparability. Comparability we already seen here, right? Here the comparability is very less. You can't compare even group 1, group 2, group. You're not able to see group 1 data in the first place. How you are going to compare? Benefits of using relative stack bar. Comparability will be good. Patterns you are going to get. Proportions you can, as I told you, like by looking this graph here in the relative graph, I can see among these three groups, in group 2, the category B is more. How did I say that? Because by looking into the graph, isn't it? And because I used relative stacked bar plot. Now, if you see proportion of category A, in which group it is higher? Group 3. Same data here. Proportion of category A is higher in group 3. Is it correct to say that? Group 3.
It's 300.
Hold on. Guys, yes, correct. We are actually going correct only. Proportion of category A is higher in group 3. This is because relative data stack bar plot we are able to tell that. This you won't be able to tell in this graph, because first of all group 3 is not visible at all, right? Proportion, so you calculate the proportion of group category A in each group. You calculate that in each group. Which group is going to give you more? Group 3. And this also, see, among these three numbers, this 300 proportion is more than 25 and 20, right? And among these three numbers, here group A is, category A is not more. Here category B is more in group 2. Here category A is more. But the proportion is highest among this here only, because you are comparing with 25 and 20. That's why in relative bar plot, you identify this pattern, which you can't identify in the absolute bar plot. Okay, so this type of analysis will be very pretty much easier if you'll use relative stack bar plot. Okay, guys, read out these benefits and try to understand whether you got this logic or not. Stacked area plot. What is area plot? Stacked area plot is a type of data visualization that displays the evolution of multiple variables over various data points using a series of stacked polygons. Polygons means what? Guys, what is polygon?
Having many sides.
Many sides. So can I say triangle is a polygon?
Yes.
Can I say square is a polygon?
Yes.
So yes. So polygon is nothing but with sides, and when you define the number of sides, then you can get a particular shape. Suppose n equal to 4, that means what? It is a square. When n equal to 3 of polygon, that is a triangle, like this. And to verify this one, let me show you first the graph. Okay, it's already there. It's already there. Stacked area plot. Can you see what is happening here? This is one category. On top of that, another category. On top of that, another category. Stacked area plot. Now here, that kind of bottom kind of thing is not there, because here we have a function which will deal automatically for us. That is called a stack plot function. Here you need not to mention the bottom and all. Just in one line you mention x and the different data of the categories. Now here how am I generating this one? X-axis is from 1 to 6. Y-axis I am generating random integer from 1 to 10 with size equal to length of x. What does that mean?
5 numbers from any 5 numbers from 1 to 10.
Everyone agree with that, right, guys? So when I say, see guys, random integer 1 to 50, that means generate me some random numbers between 1 to 50. And how many random numbers I want? 20 random numbers. This is how I'm generating the y1, just to show you. So how many I generated? Now tell me, this line code and this line code are similar, right? So that means all the y and y2, y3 data will be similar or different?
Different. May or may not be same. It's a random list. Sorry, random array of integers.
Right.
Size is,
Yeah, Divya, you're saying something?
the size is same, the values may be different.
Correct. Because this is a random number between 1 to 10, maybe or may not be same. Okay, and here after generating this x and y data, what I did, I put into this function, stack plot x, then y1, y2, y3, y4. Okay, and the labels is like polygon 1, polygon 2. And this is how I got a stacked area plot. Now it is all your duty, guys, that you need to implement this in your work environment and tell me whether it is working for you or not, whether you are going to get any insights by doing this or not. Try to implement all the plots that we learned till now. So guys, as I said, okay, I have one meeting at 11. So we'll stop today early, okay? So any questions till now? I'll come to this one. So using COVID data, we are going to plot this graph. Okay, but it will take another 10 to 15 minutes, which I don't want right now. So any questions till now? Or we'll wind up a bit early today? Is that fine for you guys all?
Yes, sir.
Okay.
I know few people will be happy today because it's getting stopped and they can live to office today. Okay, early. So those want to go, we can leave. And those, if you have any questions, we have 2 to 3 minutes. Or I'll wind up and I'll get ready for that work.
Get ready, sir. Thank you.
Okay, so tomorrow we'll start. So tomorrow we're going to start from this COVID-19 data set. So we'll load this COVID-19 data set and we're going to see the plots using this, how using the data frame, you are going to plot it. Okay, tomorrow we'll start. And I have not uploaded this file. I think tomorrow also we'll take the whole session for this one. Then it will be finished, this part. Session 19 and session 20 is all about your data visualization. And yeah, more, yeah guys, one extra file I'm providing to you along with this, that is the sample EDA work that I referred when I started. Okay, like reference EDA, how you can do an EDA on a project. There's a reference notebook. Okay, I'll upload today along with this session 20 notebook. That notebook also you try to explore if you have free time. That will give you the knowledge or idea how to do an EDA on any data set. Okay, and if in case of any query, you let me know so that we can discuss after the class. Okay, guys. Okay, so we'll wind up then. We'll meet tomorrow. Thank you, guys. Thank you. Have a nice day ahead. Yeah.
Thank you.